I am Anil Kumar. Welcome to my series on exponential functions. Here is test number 1. Let me thank my students for sharing such test papers. We'll have 11 questions rather in this test paper. Let us first go through these questions and then we're going to answer them one by one. So we'll begin with very simple concepts of evaluating the radical numbers, solving a simple exponential function. So there will be another video on exponential functions where we'll treat more complex problems related to exponential functions. Then we'll simplify such expressions. We'll write domain and range of transformed functions. We'll describe the transformation. And given the function, we need to figure out what is the image point on the transformed function, correct? And then we'll take up questions related to sketching the graph of a transformed function, writing equivalent expressions by changing the base. And then we'll have an example on how to write exponential function from the given graph. And then we'll have 2 application questions. So that is how the test paper is structured. Now let's look into these solutions one by one. Evaluate 64 to the power of 3 over 2. So you could do it in different ways. One of the simplest way could be, this could be written as 64 and 1 over 2 is basically square root, right? So we can do square root first and then we can cube the function, correct? So square root of 64 is 8. So we get this as 8 cubed, right? So 8 basically means 8 times 8 times 8, right? So multiply, we'll get this as, we can write this as 8 times 4 as 32, 2, 3. 8 times 6 is 48 and 3 is 512. Is that clear to you? Right. Okay. Now, sometimes we could ask this change base to 2 and then evaluate. So let this be question number 1B for you. Is it okay? Change base to 2 and then evaluate, right? Okay. Now let's take the next question, which is solve 3x equals 27 to the power of 1 over 3. So cube root of 27. Now that really means we are writing 3x is equal to, negative means 1 over, right? So 1 over cube root of 27. So cube root of 27 is 3, right? So it is 1 over 3. So the value of x from here we can calculate as 3 goes in the denominator, so get 1 over 9, correct? So that becomes the solution. Perfect. So for us the solution is x equals to 1 over 9. The next one is to simplify this kind of so exponential laws we are working with. One mistake which sometimes students will do is will not cube 2, right? So you have to write 2 cube also, right? Do you understand? 2 cube. The next number is a2 to the power of 3. When you multiply by 3, we get this as a square. And then b becomes b square. In the denominator also this works. So we have a cube. We get b to the power of 2 times 3, 6, but with a negative sign. Is that clear to you? Right? Now, as you can see here, the powers of 2, we could actually cancel these 2. We are left with 1 here, right? But this goes in the numerator. Perfect. So what I'm trying to say here is that you could write this as equal to 2 to the power of 3 is 8. And we have b to the power of 2, and this is minus 6, so it becomes 2 plus 6, right? Let me write like this, over a. Now we should be writing our solution with positive exponents, that's the whole idea. So I'm not writing a to the power of minus 1. So let me write this as 8, and here we get b to the power of 8 over a, and that becomes the simplified form of the given expression. Clear? Question number 4. Write domain and range of this particular function. Now, minus means, let's think about it. So minus, this minus means reflection on x-axis, correct? So that means the graph is going downwards, and this the negative one means that we have a horizontal asymptote y equals to -1, right? So y equals to -1. Now these two informations are good enough to write the domain and range for the function, right? So if you want to sketch this function, then this function will be, since this is a positive, more than 1, 3, right? So what we get here is a function which will be kind of going like this, right? Where we have a horizontal asymptote which is y equals to -1. Is that clear to you, right? So as far as the exponential functions are concerned, the domain is all real numbers, so no problems there. So we can write x belongs to real numbers, right? As far as the range is concerned, there is a restriction, and now we figured it out. We get y belongs to real numbers, where y is less than -1. Is it clear, right? It is approaching -1, but it is not quite there. Okay, so that is how you're going to answer this. Question number 5 is to describe the transformations. So to describe the transformation, important thing here is to rewrite the function with factoring out this number 2. So we get 3, 5. Factoring 2, we get x plus 3. Do you see, realize that part, correct? So that is how first step should be taken. And then you should start writing your transformation in order, right? So order should be what? Order is from left to right. If you do that, you do multiplication first, then you do plus or minus, right? So multiplication, division first, that is the order, right? So let's write down each transformation one by one, right? So first one here is vertical stretch by a factor of 3. So we have vertical stretch Okay, the second one here is horizontal compression by factor of half. One over 2, and this 3 means translate 3 units which side? Left, not 6, okay? And that means 4 units up, right? So we have translate 4 units up. So I hope that is absolutely clear, right? Now let's take the next question, which is question number 6. Given the function f of x equals to 2 to the power of x, write the image of the point 38 on the given function, right? So we are given the function f of x equals to 2 to the power of x, and the point here is 3. So if I write 2 to the power 3, I do get 8, right? The other one, g of x, is given to us as 0.5, means half, right? Times 2 to the power of minus. I'll factor out 3, right? But minus 3 this time. So I get 6 divided by 3 as 2 plus 4, correct? So any coordinate which is x and y here on the function, it gets transformed to what? Write this first, right? So x value will get multiplied by minus 1 over 3, right? That is what happens to x value, and then you take away 2. As far as the y value is concerned, it gets multiplied by half the original y value, and then you add 4, right? So these two x values. We have 3 and 8. So if I substitute this with 3, I get minus 1 over 3 times 3 minus 2. And we get half of 8 plus 4. Correct? Do you see the calculations, right? So we get minus 1 minus 2. And here we get 4 plus 4. And so we get our coordinates, which is minus 3. And we get 8. Right? So the y value is still the same. And the x value is this, correct? So that is our answer. So the transfer point is The image is what? Minus 3, 8. Is that clear to you, right? We need to sketch graph of g of x, which is equal to minus 2, f of half x minus 2 plus 4, where f of x is 3 to the power of x. So I'll actually sketch a rough graph. You should do it on a graph paper. Now, to sketch this graph, we should understand the transformations. So we are going from 3 to the power of x to a transformed function, which is minus 2 f of, so here we should take half common. So I'll rewrite this as half of x minus, so it gets multiplied by 2, we get 4, and here we have plus 4, correct? So this is the function, and that is the transformation. So in this case, how will the coordinate points change? So if I have xy on the graph of 3 to the power of x, then the value of x will now change. It will get multiplied by 2, right? That is horizontal stretch by a factor of 2. So we get 2x. And this point here will shift 4 units to the right. So plus 4. Note that if I would not have taken this common, some students could make a mistake of writing 2 instead of 4. That would be wrong. And the y coordinates will be minus 2 times the original value. So we can write this as x0, y0, the original values, right? So minus 2 times y0 plus 4. So it is reflected on the x-axis and move 4 units up, correct? So our graph basically, you can see, is going downwards now with horizontal asymptote at 4. So more or less we got an idea. Now to make a better graph, what we should do here is take some values, right? So let's take some values. We'll take few critical values which can help us sketch a good graph. So let's call this as function f of x, and the coordinate points will be x0, y0, right? Now here we will write down the transformed points, right? Okay. Clearly the transformation is shown here. Let me rewrite this. So to each value of x we'll multiply by 2 and then we'll add 4, correct? As far as the y is concerned, we'll multiply by minus 2 and then add 4, right? So that is the kind of transformation. Now one of the important points here is 0, 1. So if I use 0, the y-intercept is always 1. That is to say 3 to the power of 0 will be 1. Now this point get transformed. So 0 times 2 is 0 plus 4. So we get this as 4 here, right? And y value of 1 means minus 2 plus 4, which is 2. So we get a 0.42. Now next important point to consider is the asymptote itself, which is when x approaches negative infinity. So we can say when x approaches negative infinity, in that case y approaches 0 from above, correct? That is the horizontal asymptote, clear? Now in this case, what am I saying? I'm saying negative infinity, that will remain negative infinity, correct? So when x approaches negative infinity, plus 2 times that, it remains negative. But the y value becomes negative. You see that? Negative means it's going downwards, right? So, and we are adding 4 to it, right? So we are adding 4 to it. So it approaches 4, but from below. Do you see that? That's negative, right? So 4 from below. So this is a very critical point. And of course, in any exponential function, let me write here, if I approach positive infinity, then y also approaches positive infinity, right? So in this case, the x value approaching positive infinity, the y value, since it is negative, approaches negative infinity. Does it make sense to you, right? So that is one important thing. We could take two more points here related to the value of x as 1 and minus 1, right? So if I take 1 as the x value, 3 to the power of 1 will be 3. On this side, 1 times 2 is 2 and plus 4 is 6. And as far as 3 is concerned, we get minus 6 plus 4, which is minus 2, right? So we get 1 point here. And here if I write minus 1, I get 1 over 3, right? Which is difficult to calculate anyway. Minus 1 gives me here minus 2 plus 4, which is 2. And the value of y will become plus 2, 2 over 3 minus plus 4. So 4 minus 2 over 3. So 3, 1 over 3 you can say. Okay. So 2 over 3 if I take away from 4, so we get 3, 1 over 3. So these are good enough points to sketch the graph. Perfect. Okay. So we see that the graph is actually going downwards. So I will use, most of the points are on the positive side. So in this limited space, what I'll do here is sketch like this. So one, clearly, we do have a horizontal asymptote at 4, right? So let's say this is 4 for us. So that really means that we are approaching like this, correct? And then we have a point 2, 3. So on this side, positive side, 4, 2, right? So on this side, we have a point 4, 2. Then we have 6 minus 2. So let's say this is 4, then that is 2. And let's say this is like 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have a point 4, 2. 1, 2, 3, 4, and 2. That is 4, 2 for us. And then we have 2. At 2, we have 3, 1 over 3. So at 2, slightly more, kind of like this. So we will be approaching this part. At 6, we have minus 2. So at 6, we have minus 2, right? So, well, that could be better estimator. So we have our points here to sketch. So let me just go like this. Connecting these points with a smooth curve, we get our graph. Is that clear to you, right? So that becomes the exponential function, which is g of x. Is that clear to you, right? So these are the critical points which we should mention, which are 4, 2. Here we have 6 minus 2, and we have 2, 3, 1 over 3, okay. And this is 4, right? So we have a horizontal asymptote, which is y equals to 4. Is that clear to you? So that is how you could sketch the exponential function, transformed exponential function, where the base is 3. So I hope it makes sense. Question number 8 is, write an equivalent expression to each of the following function using the indicated base. So f of x equals to 2 times 9 to the power of 2x minus 1. We have to change the base to 3. So we can write this as f of x equals to 2 times 9 to the power of 2x minus 1. Let's change the base to 3. So we get 2 times 9 is 3 squared, right? So 3 squared to the power of 2x minus 1. So we could write this as 2 times 3 to the power of 2 times 2x minus 1, which is 2 times 3 to the power of 4x minus 2. Is that clear to you? So that is how we'll change the base. The next one here, we need to change the base to 2. So we could write this function f of x as equals to 3 times 1 over. Now 2 to the power of 4 is 16, right? So we get 1 minus x. Now this could be written as 3. Now we have 1 over 2 to the power of 4 times 1 minus x, right? So which could be written as 3 half. And we get this as, let's open the bracket, which is 4 plus x, 4 minus x, 4x. Is that clear to you? However, the base has to be changed to 2 and not half, right? This is important. So we have to flip this. So basically we should be writing like this, 3, 2, and that becomes negative of 4 minus 4x. You understand, right? So the final answer should be written as this. So this gets minus, that gets plus. We could write this as 4x minus 4. Does it make sense to you? So that is how we are going to write this particular answer. Perfect. Now let's take a small break and then we'll take up application questions. Here is question number 9 from a test paper. I would like you to pause the video, answer this question, and then look into my suggestions. We need to write equation from the graph in the form of f of x equals to a b to the power of x plus c. We are given 3 points on this exponential function, and we also see that there is a horizontal asymptote y equals to 1. The function approaches 1 as x approaches negative infinity. So from this information, you should be in a position to write down the equation. So let's see how to do it. So we are given the function in the form of a times b to the power of x plus c. So let's begin with this information, which is as x approaches negative infinity, f of x approaches 1, right? So if I substitute this value here, what do I get? If x is negative infinity, that is to say, on the right side, if I write b, here if I write negative infinity plus c, right? And f of x is approaching 1, so let me write 1 here. So anything to the power of negative infinity, we know b has to be greater than, well, we'll assume b to be greater than 1, okay? So we are assuming b greater than 1. Well, b could also be within 0 to 1, since it is growth, right? Growing function, right? So growth. So if for as a decay, it could be between 0 and 1. Okay. Since b is positive, we can clearly see that the first part, b to the power of negative infinity, will be approaching 0, right? So this is where it is approaching, correct? And so we see that the value of c should be 1, right? So that gives you c equals to 1. Is that clear to you? So this is also a very important concept. Straight from here, we can directly write the value of c. So that was to explain. So now we can write the function f of x as equal to a times b to the power of x plus 1. Now let's use this point, which is the y-intercept. And the point here is x value is 0, y value is 4. So substituting 4 here for f of x and 0 for x, we get a times b to the power of 0 plus 1. So anything to the power of 0 is 1. Therefore, we can write this as 4 equals to a plus 1. And that clearly gives us the value of a as 4 minus 1, which is 3. Right? So we got a as equal to 3. Right? So let me highlight the values which we have already got. One is c equals to 1 and a equals to 3, right? Now let's continue to find the value of b. So now we have the function f of x, which we can write as 3 times b to the power of x plus 1, correct? From these two conditions. Let's use the next point 1 and 7. So using the point, let's call this point p as 1 and 7. In that case, 7 is the f of x, and we'll substitute 1 for x because 3 times b, right? Anything to the power of 1 is the number itself. So we can rearrange. We get 7 minus 1 equals to 3b. So 6 equals to 3b. Dividing by 3, we get the value of b, which is 2. Right? So we get the value of b as 2. And now we can write down our function. So the result is f of x is equal to a is 3, b is 2 to the power of x plus 1, correct? So that becomes the solution. So this is the equation which represents the given graph. So I hope the steps are absolutely clear. I would like you to go through the complete test paper where I've discussed 10 questions from a test paper on exponential functions. Hope you understand and appreciate. Number 10. A colony with 1920 insects is doubling every 10 days. We have 3 questions related to this information. How many insects were there 40 days ago? How many insects will be there in 20 days? How long will it take them to be 491,520? So first part is to write down the equation, and then we'll look into the solution of part A, B, and C. So we're given a colony with 1920 insects, which is doubling every 10 days. So the initial amount is 1920, right? And the doubling period D is 10 days. So we could write at any instance of time, A will be equals to the initial amount times 2 to the power of T over D, right? So that is the formula. We know these two values, so I could write A as equals to 1920 2 to the power of T over doubling time is 10. Is that clear to you? So that becomes the equation. So we are always going to work with this particular equation. So the first question is, how many insects were there 40 days ago? Now 40 days ago means time is minus 40. Is that clear to you? 40 days ago, right? So part A, T is equals to minus 40. So we have to find the value of A. So A will be 1920 2 to the power of minus 40 over 10. Correct? So which is equal to 1920 2 to the power of minus 4. Right? So we have to divide this by 16 to get our answer. Is that okay? So let's do it using the calculator. So we have 1920 divided by 16. 2 to the power of 4 is 16, so we get 120 as our answer. Right? So you could do like this, or you could say 1920 times, like written here, 2, right, to the power of minus 4, right? So that also gives you 120, the same answer. Perfect. So that is how you could find the answer for part A. Okay. Now let's do part B, which is how many insects will be there in 20 days. So we'll just replace T with 20 now. So for part B, we have A equals to 1920, 2 to the power of 20 over 10. So that is 1920 times 2 to the power of 2, which is 4, right? So 1920 times 4, right? So we can just multiply by 4 and get our answer. So 1920 times 4, 7680. Now let's look into part C, which is how long will it take them to be so much? So that is the final value. We need to find time now. So we get 491520 equals to 1920 2 to the power of t over 10. Correct? So the first step is, let's divide 491520 by 1920. We get 2 to the power of t over 10. So let's do this and see what do we get. We get 491520 divided by 1920, and that gives you 256. 2 to the power of t over 10. Now in this case, 256 can be written as a power of 2, right? So you could write 256 as 2 to the power of what? Well, 2 to the power of 10 is 1020, right? So half of that will be 9. This is 8. Let's check. So we have 2 to the power of 8, which is 256, right? So we can write this as 2 to the power of 8 equals to 2 to the power of t over 10. So that means 8 is equals to t over 10. So 80 is equal to t. Is it okay? So that in 80 days, so the answer is in 80 days. So in 80 days, that is the solution. They will be 491520. Is that correct? Right. So that is how you're going to solve it. Now, since this was a good number to work with, you could find this solution. Otherwise, we may use logarithms to find this solution, right? So that is important to understand. Okay. Now here is the last question of our test paper, question number 11. Population of a city increased from 2.4 million to 4.8 million in 20 years. At what rate is the population of the city growing? So we can say our initial population A0 is 2.4 million. Now the final population we are looking at is 4.8 million, right? Kind of double, right? And the time taken to double this was 20 years. So we need to find at what rate is the population of the city growing. So right, that is what we need to figure out. So we can always use our formula, which is A equals to A0. Now it is growing, so 1 plus the growth rate R to the power of T. Is that clear to you, right? Where R is growth rate. Right. Normally 1 plus R is called growth factor. In this case, we are interested in growth rate, right? So we'll just substitute the values given to us and then calculate R. And we could write this R in decimals or in percent, right? So substituting, we get 4.8 equals to 2.4, right? Million cancel, and we have 1 plus R to the power of 20. So we have 4.8 over 2.4 equals to 1 plus R to the power of 20, correct? Which is 2, right? So 2 to the power 20th root is 1 plus R. So the value of R is basically 20th root of 2 minus 1, correct? So let's do this. So we have 2 to the power of 1 by 20 I can write, correct? And then from there we'll take away 1. So we get 0.0352 equals to R, right? So that is the growth rate. So normally it is written in percent, right? So growth rate we could write as 0.0352 times 100, which is we can say 3.5%. Is that clear to you? So that is how we could write the growth rate. And that brings us to the end of our test paper. So let me thank once again all the students for sharing their test papers with me. And I hope you learned a lot. So we actually did a couple of questions, 11 of them. And I hope that helps for you to review all the concepts. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.